Hi, I'm Ellie, and I'm a software engineer at Principal Financial Group. How to draw with your computer. We've set up our system, learned to use Git, and run our first program using the print function. Now we are ready to start using functions to make graphics. In this chapter, we will learn an important graphics library and call its functions. By the end of this chapter, you will be able to create your own art like this. We will concentrate on learning to call functions for graphics in this chapter. The same concepts we learn here also apply to calling functions for other activities like robots, data analytics, and website programming. Creating a new program. Open up PyCharm. It should start up with the same set of project files like we used last chapter. We'll use this project for all of our work in this book. Do not create new projects for each lab or program. We are going to create a lot of code samples as we learn new concepts. You should already have a folder called Scratch Work. We can put our code samples there. Create a new sample by right-clicking on Scratch Work, click New, click Python file. Name the file drawing_samples.py. Make sure it's inside the Scratch Work folder. If it isn't, drag to move it. Comment your code. Before we start writing long programs, we need to learn about code comments. When typing in computer code, sometimes we want to be able to write things for our own benefit, and for anybody else that reads the code. Since this won't be computer code, we need to tell the computer to ignore it. The Python standard is to use multi-line comments with triple quotes at the start of each source file to explain what the code does. Use single-line comments everywhere else for now. Go ahead and try putting in your own comments. Before we run this program, we need to make sure we are running the night program. If I select Run with the green arrow, I will run lab_01.py, not the program I want to run. You need to right-click on our program and select Run drawing_sample.py instead. Hey, wait! When we finally run our program, nothing happens. That's because the only code that we wrote were comments. Comments are ignored, therefore there was nothing for the computer to do. Import the arcade library. Before we can draw anything, we need to import a library of code that has commands for drawing. Computer languages come with a set of built-in commands. Most programs will require more commands than what the computer language loads by default. These sets of commands are called libraries. Some languages have their own special term for these libraries. In the case of Python, they are called modules. In the Python world, you can use the term library and module interchangeably. Thankfully, it's easy to import a library of code. If we want to use the arcade library, all we need to do is add import arcade at the top of our program. Libraries should always be imported at the top of your program. Only comments should appear ahead of an import statement. Technically, you can put the import statement somewhere else, just like technically you can wear a pair of shorts on top of your head, but don't. Trust me on this. In the code below, we've imported the arcade library. If you run the code, yet again nothing will happen. We've loaded the arcade library, but we haven't done anything with it yet. That's our next step. If you get an error that you can't import the arcade library, it hasn't been installed on your current Python environment. Go back and follow the directions in installing arcade. How to open a window for drawing. The first arcade function we are going to learn is open window. This command opens a window with a given size and title. The code looks like the following. What does each part mean? To begin, we select the arcade library with arcade. Then we separate the library from the function name with a period. Next, we put in the name of the function, open_window. Just like the print function, we surround the function parameters with parentheses. For example, if we have more than one parameter, we can use commas to separate them. PEP 8 asks that each comma is followed by a space. The open_window function requires at least 3 parameters: the window width in pixels, the window height in pixels, and the text that will appear on the title bar. In the case of width and height, The numbers specify the part of the window that you can draw on. The actual window is larger to accommodate the title bar and borders. So a 600 by 600 window is really 602 by 632 if you count the title bar and borders. So how do we know open windows is the name of the function to call? How did we know what parameters to use? The names of the functions, the order of the parameters, is in the Application Program Interface, or API for short. You can click here for the entire Arcade API or go straight to the documentation for Open Window. Any decent library will have API documentation and example code to show how to use the library. Try running the code above. It kind of works. If you have fast eyes and a slow computer, you might see a window pop open, then immediately close. If your computer is super fast, you won't see anything at all because the window opens and closes faster than your eye can process. Why does it close? Because our program is done. We ran out of code to execute. To keep the window open, we need to pause until the user hits the close button. To do this, we'll use the run command in the Arcade library. The run command takes no parameters, but still needs parentheses. You should get a window that looks something like this. Clearing the screen. Right now, we have a default white as our background. How do we get to a different color? Use the set background color command. Before we can see the color, we need two more commands. These commands tell the Arcade library when you are about to start drawing, start render, and when you are done drawing, finish render. Try running the program. If everything is correct, you should get a window with a colored background. Specifying colors. Wait, where did arcade CSS color.sky_blue come from? How do I get to choose the color I want? There are three ways to specify colors. Look at the arcade.color API documentation and specify by name. Look at the arcade.css color API documentation and specify by name, or specify the RGB or RGBA color. To specify color by name, you can look at the color API documentation and use something like arcade.color.aquamarine in your program. These color names come from the color picker color chart. The colors in arcade.css color come from the same standard color names used in creating web pages. Therefore, I suggest using these color names because it will also help with web development skills. RGB values. If the color you want isn't in the chart, or you just don't want to use a chart, you can specify colors by RGB value. RGB stands for red, green, and blue. Computers, TVs, color-changing LEDs all work by having three small lights close together: a red light, a green light, and a blue light. Turn all three lights off and you get black. Turn all three lights on and you get white. Just turn on the red, you get red. Turn on both red and green to get yellow. RGB-based monitors work on an additive process. You start with black and add light to get color. This is different than paint or ink, which works on a subtractive process. You start with white and add to get darker colors. Therefore, keep separate in your mind how light-based RGB colors work from how paint and ink works. We specify how much red, green, and blue to use by a number range of 0 to 255. No light is 0. Turn the light on all the way, and it is 255. We need three numbers to specify three colors, so 0, 0, 0 means no red, no green, no blue, black. Here are some other examples. There are tools that let you easily find a color, and then you can get the RGB value for it. If you go to the Google search engine and type in color picker, it shows a nice tool for picking colors. At the bottom of the color picker, the color is shown in hex, CMYK, and several other formats. Remember, we want the RGB value. After getting the RGB value, specify the color as a set of 3 numbers surrounded by parentheses, like the following code. In addition to RGB, you can also specify the alpha with a RGBA value. The alpha channel controls how transparent the color is. If you draw a square with the alpha of 255, it will be solid and hide everything behind it. An alpha of 127 will be in the middle. You will see some of the items behind the square. An alpha of 0 is completely transparent. What is a byte? Notice how the color values go between 0 and 255? That's strange. Why 255? Why not 100? Why not 1,000? This requires an explanation of a very important concept of how computers handle numbers. You may have heard that computers think in ones and zeros. That's true. Everything to the computer is a switch. If there's electricity, we have a 1. If there's no electricity, we have a 0. Every 1 and 0 is called a bit. We can store those bits in memory. How do we go from ones and zeros to numbers we normally use? We group these ones and zeros together to form binary numbers. These combinations of ones and zeros work like combinations of the digits 0 through 9 used to form the base 10 numbers we are used to, like this. See the pattern? It is the same pattern we used when we count as a kid. As a kid, we learn to go 0 to 9, then when we hit 9, we go back to 0 and add 1 to the tens place. Here we only have 0 to 1 instead of 0 to 9, and instead of a tens place, we have a twos place. You might have used bases in math class long ago. Computers work in base 2 because they only have 2 ways to count, on or off. Humans think in base 10 because we have 10 fingers. Numbers are stored in bytes. A byte is a set of 8 bits. If we were to follow the pattern we started above, the largest number we could store with 8 ones and zeros is, in base 10, this is 255. Let's use some math. We have 8 ones and zeros. That gives us 2 to the 8th power equals 256 possible combinations. Each combination is a different number. Since 0 counts as a number, that makes the biggest number 255. If we had 16 bits, then we'd have 2 to the 16th power equals 65,536 possible combinations, or a number from 0 to 65,535. A 32-bit computer can hold numbers up to 2 to the 32nd power, which is 4,294,967,296. A 64-bit computer can hold really large numbers. So, because a computer holds colors with 1 byte for red, 1 for green, and 1 for blue, each color has a value range from 0 to 255. The coordinate system. We've learned to specify the color of what we want to draw. The next thing we need to learn is how to position it. In your math classes, you probably learned about the Cartesian coordinate system, which looks like this. Our graphics will be drawn using the same system, but there are additional things to keep in mind. We will only draw in the upper right coordinate, so 0, 0 will be the lower left of the screen, and all negative coordinates will be off screen. Each point will be a pixel, so a window that is 800 pixels wide will have x coordinates that run from 0 to 799. 0 is one of the pixels, so 0 to 799 is 800 pixels. Off by 1 errors are very common in computing. Arcade has drawing primitives that allow you to create rectangles, circles, arcs, lines, and text. Drawing rectangles. Our screen currently has sky blue color. Let's draw a rectangle at the bottom half of the screen and make that a grass color. The function we will use is draw_LRTB_rectangle_filled. It stands for draw left, right, top, bottom, rectangle. To make the bottom half of our screen grass, we will start with a left of 0 and a right of 599, a top of 300, and a bottom of 0. The order of the statements is important. Make sure you put in your command after the start render and before the finish render. Your window should look like this. Sometimes we don't want to specify a rectangle by the left, right, top, bottom. There is also an option to specify it by center X, center Y, width, and height using the draw_rectangle_filled function. For example, this code displays a tree trunk. There's also a function to draw the outline of a rectangle called draw_rectangle_outline. Both of these functions, and many others, have an optional parameter to tilt the rectangle to a desired angle. Drawing circles. We can draw a circle with draw_circle_filled. This code will draw a circle with a center of 100, 350, and a radius of 30 pixels. Drawing ellipses. If you don't want a perfect circle, you can draw an ellipse. Ellipses are drawn like rectangles. The rectangle forms the bounds of the ellipse that's drawn inside of it. Examine this code sample. Now, look at what it draws to understand the relation between the rectangle and ellipse. With the draw_ellipse_filled function, we can make a tree out of the tall ellipse for the top. Drawing arcs. You can draw an arc with draw_arc_filled. Drawing an arc works just like an ellipse, with the additional parameters for a start angle and an end angle. Triangles. Triangles are drawn by specifying the coordinates of each point with draw_triangle_filled. That requires a bit of thought about where each point goes. I often end up sketching it out on a paper to get it straight. This can be used to make a pine tree. Polygons. Polygons are drawn with a list of points and the draw_polygon_filled function. In this example, we use 5 points to create a tree top. Lines. Line drawing with the drawLine function involves specifying a start point and an end point. Optionally, you can specify the line width. You can also use the draw_line_strip to draw a continuous multi-point line. In our sample image, we'll use several lines to draw rays coming out of a sun. Text. Text can be drawn with draw_text command. Just like with the print function, text must be enclosed in quotes. The text to draw is the first parameter. The x, y location of the text are the next two. Finally, the color and font size comes next. Specifying parameters by name. It can be confusing to track a lot of parameters given to a function. For example, here's a call to a draw_arc_outline. It is not easy to track what numbers go with that parameter. Yes, the parameters have an order to them, but unless a programmer memorizes every order of every function, you can't quickly tell. Parameters each have a parameter name, which can be found in the documentation. We can use that name to specify each value given to a function. This may take some additional upfront coding time, but the increased readability may save time later. Future improvements. Looking forward, there's a lot that we can do to improve this code. In variables and expressions, we'll learn how to use variables to store our parameter values, which will enhance the readability of our program, while giving us more flexibility to update our item's positioning. In drawing with functions, we'll create our own functions. That will allow us to create a function like drawTree. Improving graphics performance. If you create awesome graphics using these commands, you might find later when creating a game that drawing graphics in this manner is very slow. Computers redraw the screen about 60 times every second. Complex drawings can have hundreds or thousands of points of data to draw. Multiply that by 60, and it's quite a bit even for fast computers to handle. To speed graphics, computers have separate processors to handle the display. To use those separate processors, we'll need to draw in two steps. First, the computer will collect a batch of points, colors, and drawing information together. Then it will send all of that information to the graphics processors. If you've experienced a long pause between levels when playing a game, this is what's happening. After the graphics information is sent to the graphics processors, anytime our program wants to draw a tree, a house, or a rainbow unicorn, it tells the graphic processors simply draw the unicorn, rather than resend all the individual drawing commands. As we progress through the class, if you find your drawing commands get too slow, keep this in mind. The arcade library supports batch drawing with sprites and shape lists. We'll cover how to do this in future chapters. Real-world applications. We aren't limited to the arcade library and its API. Here are a few other APIs to give you an idea of what's out there. OpenPyXL for creating and processing spreadsheets. CircuitPython has a set of libraries for controlling LEDs, motors, displays, and robotic servos. NumPy is a powerful library for working on anything related to linear algebra. Beautiful Soup is a library that allows your program to automatically download pages off the web and process the data in them. Review. In this chapter, we learned how to import a Python module. We learned to call functions from an imported module. While we are learning how to do graphics in this chapter, these same skills can be used for importing and calling libraries of code that manage spreadsheets, images, robotics, and more. Colors can be specified in RGB format and are stored in bytes. Each byte is a group of 8 bits and can hold numbers from 0 to 255. We learned how to draw ellipses, arcs, rectangles, triangles, polygons, lines, and text. More importantly, we learned how to look up these functions out of the API documentation.